Afternoon. I'm going to convey three ideas, hopefully. Number one, transformations are everywhere because you can fit the problem to the tools. Number two, an increasingly large percentage of problems are going unsolved. We heard this morning about whether or not innovation is increasing or lagging, and it's pretty clear to most that we're lagging, and I'm going to suggest to you it's because we're struggling with transformations that don't make sense. And thirdly then, a new kind of tool invites you all to invent more appropriate transformations. The rest is up to you. What do we mean? Well, we transform things because view A is too great in extent, variety, and ambiguity to deal with. So we come up with a transform that generates view B that contains much of the same information that we had in view A, but is much easier to manipulate. And that then can be used to generate view C, and in fact that's why these little devices can show movies at about 5,000, 6,000 to 1 compression relative to what it started out with over here. Another Hilbert transformation is shown here. Ground penetrating radar, overflight. There's a macadam, there's a surface, there's a tarmac, and there are the graves. Another transform resolves paradoxes. Paradoxes come when you take facts about parts and they don't seem to make sense. And when you transform it to the whole and look at a systems view, it all makes sense. How many transforms do you use in your life? You're all familiar with UVW to rho theta phi, aren't you? The polar coordinates, the Navy uses them all the time. You certainly use Laplace, Fourier, and fast Fourier transforms. Step PDES. All musicians know how to transform a tune from A major to C major to A major. Most people are now beginning to get an inkling that there's a transformation that can happen. There's a relationship of knowledge, mass, and energy. Other transformations are the form dog chases cat, which can be transformed to canine pursues feline, somatic transformations. And in fact, a whole bunch of people at ISO W3C are trying to make a semantic web that allows computers to exchange data with each other. The astronaut's photograph is an interesting transformation. The question of how the astronauts can navigate got to be pretty thrilling because it's a great, great big set of equations until some smart guy came up with the photograph, which is momentum space. And that reduced Neil Armstrong's navigation to a 10-inch circular slide rule. And with that, he could go from anywhere in one orbit to any place in another orbit. And some people even know how to transform fear, particularly in the product development team, into enthusiasm. And you all live under these kind of transformers, you see. And we're all familiar with transforming electricity from one form to another, but we don't often think about the other kinds of transformations. So conceptual blending, the psychologists are now showing us that the brain is a wonderful transformer, and we can now blend reason and intuition, store and retrieve versus regenerate, and can you name this tune? The next big transformer coming along is to get past the stored program computer that we've been using for 80 years and to an autonomous complexity navigator, a device that when attached with a coprocessor to an arithmetic processor will have great benefits similar to the way graphics and COMNAT. The reason is because when we get into modern problems like molecular medicine, here's a disease process at this layer, here are the cellular processes, he's interrelated with that, here are the molecules and how they react interrelated with that, and down here are the things we can observe. And there's a 4-level transformation of tremendous web complexity. Computers were designed to do arithmetic. They don't know how to deal with these kind of problems. So we replace gate count with memory space, get away from fetch, load, and operate, and into computing space. There are things like years ago, DSP, FPGAs, neural networks do some of this very fine, but at 1,000 times slower than we really need. And there are now new devices coming along that make this operate at gigabit rates. Here's what one of them looks like. It looks very much like, in fact, the organization of the brain. Stimuli come in, they're recognized, they're clustered into neurons, and then they make sense of them out here at the logical level. This thing is 1,000 bytes wide, each one of these boxes, and 2 to the 30th logical levels deep. So it can make sense out of a whole lot of stuff. And it costs about $500. These kind of things may help us solve these trillion-dollar embarrassments that we've been fumbling with for well over 2 decades. And here's why. We're going to have to take a tenth of a billion to 1 to 7 billion people, take a DNA sample each quarter from each person, look at 10 of the to-be-determined antibodies. They have to be 2 to the 3rd genes or greater than 10 to the 6th patterns, 2 to the 4th diseases classified by patterns, etc. And it'll take somewhere around 1,000 therapies available, classified by disease patterns. And oh, by the way, each person varies 80 to 1 in their uptake of drugs. So what we have to have very soon is exabytes of data processed at petabytes per second at about 100 times less cost than we do today. Lots of search have been going on for 50 years, but not much find. When you run a query through Google or whatever, you get an output, 80% of which is trivial, 20% is relevant. What you don't know is that that represents only 1/4 of what's out there that really is relevant to you. As a browser, you don't care. As a warfighter, it's fatal. We now can take a pile of software, 10 million lines of code, and verify whether there's any fault or error in it in less than 1 second. We can do that from the design level of language to the assembly level. And we can not only find angelic problems, but also what we call demonic problems, which says it worked fine when I was using it, but when you use it, it didn't work very well. And it can do it if the developer, the source of the fault was any of those places, so cyber attackers don't bother us anymore. The other transformation that is really useful now is the transdisciplinary knowledge. And this is the main reason why we're not solving problems, because we don't know how to talk to one another. And here's an interesting little model put together by Professor Rayo that says, hey, you go out there in the world of mathematics, there's only 4 factors that make a difference. And if you arrange them properly, everything fits. Look at this. Here's a number system. Here's a function as a power series. Same 4 patterns. Here's a Fourier series of a periodic function. Same 4-factor pattern. Here's generalized function. Here's a Laplace transform. Here's a Fourier transform. See the system's view of all these individual pieces? Here's a Mellon transform. Any questions? Thank you.